Enzyme action. So you recognise the term specific, so specificity when we talk about enzymes, because as we know that there's one type of enzyme that binds and matches one type of substrate. And when they bind together, you would have been introduced in third year and we would have spoke about it in fourth year in relation to the lock and key theory. Okay, so the structure of the active site on the enzyme, okay, binds on perfectly to the structure of a substrate. So for one type of substrate, there is one type of enzyme. And this is what we mean by specific. So as we've just spoke about activation energy and the importance of activation energy, we're going to show you structurally what happens at the active site on the enzyme. Okay, so here we have our enzyme. Here we have, so the orange represents the active site. Okay, and here we have our substrate. Okay, so what we see is that the substrate has a high affinity for the active site on that enzyme, and what that means is there's going to be a high want, a high pull between the substrate and the enzyme. They're going to want to come together as such. Okay, and what happens is that substrate binds on, so substrate here binds on to that enzyme, okay, and it creates this, what's classed as the enzyme substrate complex, just the enzyme and the substrate binding together, okay. But when this happens, there is a ever so slight change that occurs at the active site to therefore create a tighter fit, and this is what we mean by the induced fit. We require this induced fit, okay, to start this process of lowering or reducing the activation energy. We're also given a greater increase for the reaction rate to take place. Your teacher might have also mentioned the word orientation as well, and orientation is really just making sure that the shape of the active site and the structural shape of the substrate is coming together correctly to make sure that this induced fit occurs. Okay, so what's happening here, as it says, enzyme creates induced fit. Okay, this is the reaction occurring and therefore reducing this activation energy, because the reaction is the breakup of the substrate into the individual products. Okay, so what happens is, as soon as this lowering of activation energy occurs and the bonds break that's been held within the substrate, what happens is you're starting to form your products, and the products therefore have a low affinity for the active site. So that therefore means that once they want to be released, they don't want to be with the enzyme anymore. So because the substrate has a high affinity, it'll pull for the enzyme, but remember, we no longer have the substrate, it's products that we have. So therefore they have a low affinity, which will naturally want them to come away from the enzyme, i.e. be released from this reaction as such. So substrate, high affinity, wants to bind onto the active site, binds on, forms this enzyme substrate complex, and goes through a process of a tight fit, an induced fit at the active site to therefore make sure the reaction takes place. The activation energy is lowered, and as the activation energy is lowered, the substrate starts going through the process of being synthesized into the individual products. The individual products have a low affinity for the active site and is therefore released.